What's up, my mathletes? That's right, Mr. Muscarella coming at you. And in this video, we're going to take a look at the relationship between the degree of a polynomial function and the maximum number of possible turning points of said polynomial function. So just kind of taking a look at this relationship here between turning points and the highest possible degree. That's right, there's a little formula for it. And the formula is that the degree equals the turning points plus 1. So if I were to solve that equation, so to speak, for the phrase turning points, that means I got to take this plus 1 and move that to the other side. So turning points would be the equation turning points equals degree minus 1. So that'd be the equation for the number of turning points. So depending on which way we go with things, that's what we would take a look at. Memorizing those two pieces because they're very, very critical for that. So make sure you memorize those two values because when we take a look at this, you know, the polynomial functions, you're just going to analyze the degree of the function. This first one, the degree is 5. So that's the degree. So the maximum number of turning points is 1 less than that. So 5 minus 1, that's right, bro. We got a 4. So the maximum number of turning points for that particular polynomial would be 4. How many it actually is, we'll investigate that in a moment in Desmos. But for now, let's take a look at example number 6. Degree here is 4, so that means 4 minus 1, our maximum number of turning points would be 3. Now that doesn't mean there are 3, it just means there could be 3 turning points. And then when we take a look at these other two examples down here, number 7, the degree here on this one is 6, so that means the maximum number of turning points would be 5. And similarly, if we take a look at example number 8, maximum number of turning points on this would be, that's right, 2. So those are the possibilities for the maximum number of turning points that each one of these polynomials could have. They could have that, or there could be fewer. So now what we're going to do is we're going to take this very first equation right here, this polynomial of x to the 5th minus 4x cubed plus 5x plus 1, put that into Desmos, and then sketch it. And let's figure out the actual number of turning points from the graph. So go and hit pause. Put the function into Desmos, and then choose an appropriate viewing window so that you can see any and all possible viewing points. Go ahead, hit pause, I'll wait for you. All right. Now when we take a look here at our polynomial, we can clearly see that the polynomial, we've got this, and when you click on the polynomial, you'll get some gray dots that show up on there, which is really cool. So we'll have one turning point right there, that negative 1.365, another one down here, and then we'll keep increasing. Our y values are increasing until we get to the top of that hill right there at 0.733, comma 3.301, and then it'll turn around, so we'll go from increasing to decreasing down here and bottom out, so to speak, at 1.365. 2391. So this particular function does have 1, 2, 3, 4 turning points in that. So the maximum number of turning points possible was 4, and the actual number for this is actually that same number. So again, go ahead and do a sketch of that function so that you would have that there for your reference. So now let's go ahead and pause video again, take a moment and input equation number 6. Go ahead and place that into Desmos, and let's see how many actual turning points that this particular function has. Now when we take a look at this one, wow, check this one out. We do end up with 3 turning points on this one also. We've got this guy right here, boop, at negative 1.301 and negative 6.514. Those are the coordinates of that turning point. So again, on this one, we go from decreasing to increasing. Our y values are getting smaller. Then we bottom out at negative 6.514. And then we start to increase our y values all the way up past the y-intercept of 0, negative 3 to this value right here at 0.17, negative 2.916. And then we'll decrease again on the other side till we hit this last and final turning point for this particular function. So again, there's a sketch of that one. So go ahead and put the other two functions and sketch them, and then we're going to come back and talk about the other names for said turning points. All right, so go ahead and hit pause. I'll wait for you, and I'll be right here to support you when you get back. All right, so once we get our sketches in for number 7, you should actually see that there are 3 actual turning points, and on number 8, we didn't have any. There are no turning points on that one. So let's kind of review a couple of terms here for each one of our turning points, because we've got lots of different options here. Now, if we take a look at number 1, a sketch on that, This guy right here, where you change from decreasing to increasing, meaning the slopes or the y values, when your y values decrease then start getting bigger, that's going to be called a relative minimum. And that is going to go tie along with that last question that we're going to look at here. And then this guy right here over right there, when we change from increasing to decreasing, that's going to be a relative maximum. Ooh, I don't know what happened there on that M, but okay, so it's a relative maximum. And then similarly, we've got some other extrema going on down here at those two spots right there. So all these extrema, they fall into several different categories. So the other names that get associated with turning points are going to be these extrema. So the extrema, they come in 4 flavors. So extrema is another way we can look at this with more specific terms. So extrema is going to be a relative max, an absolute max. So that would be the highest point on a graph, the highest y value, the value of the highest y value. That would be the absolute max. And then we could also have a relative minimum or the absolute minimum. And we usually abbreviate absolute ABS and minimum MIN. That's fine. And then relative, you can just abbreviate that REL. That's accepted in a lot of math classrooms. So when you take a look at that, the extrema, those are going to be the 4 specific terms associated with turning points, depending on what's happening here. So be sure to check out another video that describes that for a little bit. And other than that, that is it on this section. Pretty straightforward, easy peasy stuff. Just got to remember that one formula. Turning points and degree, what their relationship is between the two of them. Because sometimes you'll be given just the degree and you have to figure out how many turning points there are. And other times you'll be given a number of turning points and have to go backwards and find the degree. So those 2 formulas will help you out just like I will. All right, so if you need anything, you reach out anytime, I got you. Otherwise, you guys make it a great day as always. And I'll catch up with you soon, my friends. Peace out.